One.
Welcome, everybody. We're glad to have you here with us. We're excited to talk about our topic today. Today's webinar is the DevOps.com webinar. Our topic is we've solved for availability, not to solve for hybrid cross-cloud latency, aka no data left behind. My name is Mitch Ashley. I'm going to serve both as the moderator, host, but also a participant. And I'll talk about that in just a moment. So let's cover some housekeeping here. Just a few things. One is we're recording this webinar, so feel free to take notes. Feel free to step back. You'll be able to check things out. Also, we'll be sending you an email with a link to the recording and also the slides. So you'll have all that material. Lots of good content here. So as one of those, I think you want to really be engaged. Speaking of which, our webinars are hosted on this platform called Big Marker. And one of the benefits of Big Marker's got a great chat feature, Q&A features, things that integrate well with the conversation. So I'll be posting some comments, questions while our speaker's talking, not to distract from him, but just to kind of help us contribute to that, because he and I are going to be having a discussion about the topic as we wind up on a few slides. So let's get to our topic right now. No data left behind. I have a pleasure of speaking with and being on the webinar today with Andre Srinivasan, who is Global Solutions Architect with Redis. And he is going to share with us some really great information about how data fits into the whole picture of the cloud and cloud architecture and moving to the cloud. I'm Mitch Ashley. I'm CEO of Accelerated Strategies, an analyst firm that focuses on digital transformation, DevOps, cloud native, and security. So I think we'll have an interesting conversation. So Andre, I'm going to turn it over to you. If you would take it away, just for our audience, do we have maybe about 20 minutes to 30 minutes of slides? And then we're going to be having some conversation. So we'll have a little bit of a multimedia approach here. So Andre, if you want to go, I'd love it if you would just introduce yourself and tell us a little bit about the company.
Sure. So my name is Andre Srinivasan. I am a solutions architect with the Alliances team at Redis. And Redis is the home of the Redis database, both the community version and the commercial version, Redis Enterprise. Been at Redis for a little over 3.5 years, and actually held a couple different jobs within the org, but currently with the Alliances team. So let's just get into the presentation. And as Mitch mentioned, trying for about 25 minutes or so of content, and then would welcome a conversation from that. So when I was thinking about how to speak to no data left behind, I wanted to figure out how to kind of break it down into chunks. And I started thinking about latency, location, and legacy. And basically, I'm going to try to organize everything around those categories. And when I was trying to organize around this, I came across this great deck. I think it's actually an IBM deck. There were no app left behind, but I like the picture, and it's the idea, right? It's how do you move from monolithic to modern? This thing is absolutely a journey, not a sprint. So let's start breaking it down between latency, location, and legacy. And within these categories, I'm also going to try to use a couple of examples to frame some of the challenges that we're facing. So let's start with retail, and retail specifically during the time of now, right, the pandemic. Things have kind of changed a lot. I know that in my particular case, when I'm thinking about going to the store, I'm kind of planning it more than I used to. Is the stuff there? Can I get in? Can I get my stuff? And can I get out? And effectively, what I'm doing is relying on a real-time inventory system to be accurate and to visualize that information to me as a consumer. If I get to the store and my stuff isn't there, or a subset of my stuff isn't there, I don't know about you, but what I do is at this point, I abandon everything and I just leave. That has a direct impact on the business. And technically, the real-time inventory system wasn't down. It was just slow. But that slowness, that latency, was effectively down from my perspective. I couldn't use that system, and so latency was effectively an outage at that point. And let's take that same notion of latency and look at financial services. And in this context of the pandemic, we're seeing a lot more digital banking or dependency on digital banking and digital transactions. And because we're using those systems more, there's more of a need for counter fraud because, as you would expect, there's an increase in attacks and fraud attempts. Our challenge is, if we want these counter fraud systems to be working correctly, they really need to incorporate real-time information during the fraud detection. So they need to have an accurate picture of who I am. They need to have an accurate picture of my behavior, of transactions that I probably would perform. And for the most part, the transaction systems, as these fraud systems that are designed today, are designed to operate on static data during the course of a transaction, so basically in real time. They can't incorporate that dynamic information during the course of detecting fraud. So what that does is it basically opens up an opportunity for an attacker to leverage the fact that the update of data in these counter fraud systems is effectively slow. So latency is an outage. That fraud will ultimately get detected, but probably after the transaction completes. And chasing fraud after the fact is its own set of challenges. From my perspective, as a participant in the system, that latency again represents an outage. Now let's move. So that's the latency side of data being left behind. And now let's think about location. There's kind of an interesting couple of elements of location in all this. There's that logical distance of data from where it's being used, and then there's this ability to take advantage of the scale as you move out from, say, on-premise on the right-hand side of the slide to hyperscalers on the left-hand side of the slide. And when I say scale, I mean that encompasses everything from availability to continuous operations, right? Because it's pretty hard for me to accomplish what on-prem, what I can accomplish in multiple regions or across multiple clouds in terms of overall availability and continuing to operate even if there's a variety of failures. So my data left behind from location has these different different facets of I want to be as close, or I want to reduce the distance between where the data is being consumed and where the data lives, and I want to make sure that I'm balancing where I put the data for these for availability and continuous operation. And if we just go all out and say, well, what if we were to look across all the clouds? It turns out that by thinking about using multiple clouds, we actually can start to achieve both ends of this gradation. For example, AWS wavelength is a zone that tends to be close to cities, close to manufacturing. The intent is to reduce the latency between where data is being used and where data is living. And if I'm in a couple of these clouds, I can start. I really can start to mitigate the risk around disasters and have that sense of continuous operation despite possible zone or region failures. And then finally, in terms of my three contexts, let's talk about legacy. And I mean, when I was again preparing for this and trying to understand the scope of what we're talking about, I mean, this kind of struck home. We have relatively old systems that hold potentially or hold over 50% of data siloed in these legacy systems. And it is absolutely the case that something needs to be done, but in the sense of, how do we get it out of these systems? But change is hard. I mean, think about it. I mean, these systems have been running for quite a while. The skills that were there to build them may not be there so much. Support from the vendors may not be there so much. And we can't sacrifice, right? We can't just lift and shift. We can't stop these systems. We actually have to keep these running with any strategy when we're trying to figure out how not to leave this legacy data behind. Now, if we don't do anything, we risk getting into a situation like buying 8086 chips on eBay to keep our shuttle program running. I mean, agreed, this is sort of an extreme, but I mean, this is really what we're ultimately trying to figure out how not to get into. And so, you start thinking about these problems, and you really, at least I did. I stepped back and said, I thought, could have sworn that we'd solved these problems. Why are we still talking about this? And I think the progression here is what kind of helps explain what's going on. So starting from left, going left to right, when we started thinking about modernizing architectures, we had our relational database. We then, in order to try to get a little bit more performance out of it, we split our operational database into, we split our relational database into operational databases. We then tried to get more performance out of this, and we moved to specialized databases. So depending on the shape of the data, we'd use a particular kind of database for that particular data. And when we shifted to specialized databases, we did do a nice job at increasing performance. We kind of did ourselves a little bit of a disservice in creating multiple copies of the data and potentially risking consistency. But we even were able to start to speak to that. So the shift to event-driven microservices. We can use an event bus to make sure that, or at least try to make sure that there is a consistent set of data in all the copies. Now, the trade-off here is that we keep increasing complexity, but we, from going from our original system to where we are, we've made improvements in terms of performance overall. We also, along the way, solved for availability very nicely. And where we ended up is check availability. Consistency, yeah, I mean, still some risk here, but doing a pretty good job. Our systems have become incredibly complex, and I would argue that while we've done a pretty good job with latency, we haven't necessarily tried to architect around or try to architect for latency. Now, if we come back to so data left behind by latency, data left behind by location, and well, actually, I'll move on to legacy in a moment. But data left behind by location, we do want to make sure that we're dealing with our continuous operation. We do want to make sure that our data is being consumed close to where it lives. Now, we can't simply pick up one of our deployments and put it in several places around the world, because we've basically gone back to our consistency challenge. What's which is the master, which is the system of record at this point. Where's the master data? We can't just blindly deploy like this. And then data left behind, our data left behind from legacy. In these architectures, we really haven't attempted to solve for that 50% or over 50% of our data. So here's where we cue the transformation interstitial, the don't panic. We absolutely can solve for this. And so then the question is, okay, well, where do we start? And for me, the best place to start is, where do we need to get to? We do want that data being consumed close to where it exists. We do want continuous operations. We do need to deal with data that's on-prem, because at some point we are going to have to interact with that legacy system. So basically, we know that we're going to need an architecture that can be deployed on-prem and be deployed in the cloud. And so we're talking about ultimately a cloud-native architecture. It gives us that ability to accommodate all the requirements in terms of deployment. And that means that we're taking advantage of containers and microservices and orchestration. So we're going to need a platform to run that on. There are lots of choices in terms of platforms. Kubernetes is at this point very popular. It's very easy to hire people that are knowledgeable in Kubernetes, and there are lots of implementations of Kubernetes, open source and commercial versions. I'm showing OpenShift here, one of the more popular implementations. And if we kind of step back and remember, one of the reasons that we're trying to modernize, that we're trying to figure out how to get our data out of the legacy systems, is support. And so when you're thinking about that platform, you really do want to think about, am I going to be supported this year, next year, and 10 years from now? So we know that we're going to a cloud-native architecture. We have our OpenShift platform, and we can start out with our legacy data on-prem. And we know that we can take that same platform, that same architecture, move to a cloud, so a hybrid cloud scenario. And when we're ready, we can move to hybrid multi-cloud. Again, because we've designed our architecture to be ready for that. Now, I mentioned, or actually Mitch and I both mentioned, that I am a solutions architect at Redis. And I happen to know Redis Enterprise well. There are lots of ways of solving latency. I'm going to choose the tools that I'm most comfortable with. And so when we think about designing for low latency, one of our core design premise is, how do we operate at sub-millisecond latency? How do you interact with data in less than a millisecond? And how do you do this so that it scales? The design of Redis Enterprise is to be able to scale vertically within a single node, so take advantage of all the resources on a node, and scale horizontally across all the nodes in the cluster, and do this in a linear fashion. This particular example in this particular example, what we did was demonstrate going from 1 node to 40 nodes with near linear scaling, and ultimately achieving 200 million ops per second while maintaining that sub-millisecond latency. Now, I have my platform, OpenShift. I have a data store that I can use that provides me that low latency, so I can start thinking about my data left behind from latency. Or if I update my architecture and modernize my architecture, I can hopefully achieve no data left behind. through latency. So let's come back to that counter fraud example, where I have in my current system, I can operate on static data, but I can't incorporate real-time data and still achieve that real-time during a transaction fraud detection. And if you recall from the architecture evolution, I don't want to end up with a super complex architecture with too many moving parts. What I can do with Redis Enterprise is take advantage of multiple data models. So not only the core data structures, strings, hash, sorted sets, but time series and probabilistic data structures. I can take advantage of all these data models, and with a single low latency data store on top of OpenShift as a platform, I can rebuild as a collection of microservices and achieve that real-time fraud detection that's also incorporating dynamic data into the fraud detection. And the dynamic data, again, is behavioral information about me who would like to perform the transaction, knowledge of past history. Have I done this before? So we can now revisit that architecture and solve for latency. We can take, as we've already said, we have an architecture that will run on-prem and in the clouds. So we can look at our data left behind through location. We can take this deployment, because when we're talking about fraud detection, we definitely want the system to be running within 100, 150 milliseconds at least, or at most, of where the data is being used. We don't want it to be 300 milliseconds, 700 milliseconds away from where it's being used. So we need those multiple deployments, and what we do is we replicate data in using active-active replication. In other words, all the deployments are masters. Updates to one deployment results in all the deployments being updated. The fact that we're sitting on top of Kubernetes means that we have an orchestration layer that's making sure that if a node fails, we have failover to our secondary node. Redis Enterprise is doing something similar in terms of data shards. If a data shard fails, we have failover to a secondary. So where we end up is not only consistency with all of our distributions or deployments of this solution, we haven't compromised on any of our other principles in terms of availability. So finally, we're back to legacy. We still have we still have this siloed data that we would really like to slowly and carefully start pulling out and using inside of our modern architecture. Turns out that there's a supported event-driven system, command data capture. Sorry, I apologize. Change data capture, CDC, that allows us to integrate with these legacy systems, and should that system not support CDC, we can also use text files, so CSV files, log files, and the whole point is we create an event-driven architecture of changes that are happening in that legacy system. As those changes occur, we can then incorporate those changes into our low latency data store, Redis Enterprise, in this particular example. Now, the beauty of this process of using CDC is we're not limited to just blindly taking the data as is. We have an opportunity to transform the data. So for example, let's say the data that I'm trying to move out of my legacy system is intended for analytics and visualization. What I can do is I can transform that data and insert it directly into a time series model, and then expose that time series model to various visualization tools. And so I'm not simply doing a one-for-one replication of the data. What I'm doing is I'm actually enriching the data and using it in my modern architecture. Coming back again to our counter-for-it example, if we think about a payment, the payment side of a larger system, it's most likely part of that legacy architecture. And there's no way in the short term that we can pull the larger payment system out. But we really want to incorporate that payment history and knowledge about what's happening into our fraud detection, into our real-time calculation around whether we should allow this transaction to occur. We can use CDC to create a cache of all that payment history. We can index it, because remember, we have an opportunity to transform that data. So now, as changes are occurring in the payment system, we're seeing those events through CDC, we're updating our cache, and when a transaction comes through, we can do a real-time lookup to decide, have we seen this before? Does this make sense? Should we allow this transaction to go through? So full circle. We started out with no data left behind, and what we have done is figured out how to unlock our data. First start out with an architecture that allows us to deploy this on-prem with an eye towards hybrid cloud and then hybrid multi-cloud. We use active-active replication so that we don't have a one system of record floating out somewhere that's at risk of being lost. So we have consistency across all of our deployments, and we're positioned when we're ready to ultimately get to that hybrid multi-cloud. And that's my presentation.
Awesome. Fantastic, Andre. I had a little bit of flashback there when you were showing the tapes and and horizontal spinning drives. It just reminded me of how the world of replication, really helped transform us out of that sort of tape drive world into thinking of everything digital. And a lot of replication was initially used just for that backup. Of course, we're in a much different world today. So I want to encourage folks to pop into chat, pop into Q&A section, and we've got a few questions in there already. I wanted to start out, being in this business for a while, I sort of have come up with the adage of, data analysts never go away. We just replicate their data. It seems like that's the world. No data ever goes away unless we lose it for some reason. I'm curious. You have these three generations, right? The on-prem, the hybrid, the cloud, and the distributed cloud. It seems like that's part of this complexity of data. It isn't moving everything to the cloud unless you're greenfield or really fortunate. It's you don't want the two boats pulling you apart, right? You've got a foot into both and you're trying to manage that. What are some of the strategies, Redis, OpenShift, in this hybrid world that you've seen customers or you yourself have learned from?
Sure. So, and this isn't specific to any of the technologies. I mean, once you have this infrastructure that can run on-prem and in the cloud, and you have the ability to see changes in your legacy system and incorporate that data into your modern architecture, you're in a perfect position to cherry pick the data that you want to move. Maybe kind of in that last example where I'm caching payment information to incorporate into counter fraud. Maybe that's all you're doing. Maybe you're simply pulling information out so that it can be used in a low latency requirement scenario because you're legacy system doesn't support it. On the other hand, if you have the ability, you actually can go full hog with a blue-green type strategy, keep both systems live, because that CDC process is propagating exactly the changes that are occurring in your legacy system, and then decide, when everything feels like they're operating the same, then you can do that switchover. And then the thing in between those two scenarios, cache and blue-green with an ultimate switchover, is, and in the microservices world, I think it's called the strangler pattern or something violent like that. But basically, the idea is you identify the data that you do want to move. You use something like CDC to move that data, and then you cut at some point using it on the legacy side, and you only use it on your modern application side.
Interesting observation. Another factor, and I want to thank the folks at Red Hat Marketplace. They're sponsors of our webinar today. I wanted to say podcast, but since I have my podcast microphone here with me. One thing I was curious about too is you were talking about data in the format that it's in, sort of this transformation of data in place, or as part of an architecture, as opposed to, when we think of replication, at least we used to think of it as strictly as I'm taking data and just replicating it everywhere and keeping it in sync and whatever, based on whatever policy, frequency, et cetera. How does that transformation from different formats or aspects of data into a way that it can be used in a productive way across a message bus, across containerized environments, across a distributed application, hybrid or not, or maybe all cloud even?
Sorry, that missed the question in there.
Oh, I'm sorry. It was a long question. Talk about the role of that transformation from different formats of the data across, sources that you're replicating it from and to.
Right, got it. So if you go back to those, I had that picture, the three architecture picture, the transition from relational to event-driven microservices. And if you remember in there, there was this evolution to specialized databases, and that pattern continued into the event-driven microservices architecture. What we're doing is we're speaking to exactly that. I mean, it makes sense. I mean, one shape of data does not make sense for all use cases. I mean, take time series specifically. If you can organize your data into a time series model, there are tools that you can easily point at that for visualization. I mean, Grafana is one of the more common things that you would use, or at least that I would use. So that notion of optimizing the shape of the data for its use is I think the whole point there. I guess you technically could treat everything. So in Redis, the most universal data structure we have is a hash. You can think of it like a row of data. Technically, you could put everything into a hash, kind of like you could put everything into a row in a relational database. And maybe that's optimized for write. Maybe that's a great way to write the data, but it's probably not a great way to read the data. And so if you can think about that, think about the fact that you do want to organize your data into specific models, and then take advantage of those models. You can decide, sure, I want to use multiple specialized databases, or again, for me, I can use multiple models within a single data store.
It brings with it its own another layer of complexity, if you will, doesn't it? Hey, I wanted to get to a question from Amar, who asked a really good question. He was asking about use cases of Redis over Cassandra. You had showed a chart with Cassandra on the left with a number of other technologies, and is it Redis as opposed to Cassandra? Is it Redis with Cassandra? Is it either, what's the right way to think about this? What are some use cases where you would use it?
So I mean, they're both great products, and probably not a great forum to start digging.
So we're doing product reviews of both now.
Right, right. But I think a couple of different ways to think about it. First of all, look, if you have in-house Cassandra expertise, well, I mean, don't mess with a good thing, right? Take advantage of that and build a fantastic architecture on Cassandra. I think, when we think about Redis Enterprise, when we're positioning Redis Enterprise, what we're looking at is how do we solve near real-time problems, and how do we solve those near real-time problems in potentially a distributed scenario. So multiple active databases, across geos.
Mm-hmm.
And so I would say, this is less about Redis Enterprise versus Cassandra versus Mongo, and it's more, what problem are you trying to solve? If you're trying to solve for near real time, it's kind of hard to beat Redis in that. If you have if you have a use case where you absolutely need to know that your data has been hardened to disk, and that you absolutely have to be able to roll back in any possible scenario, Redis is probably not the right product for you. It's that, there's gradations, right? You're solving different problems, and you choose the right tool.
Appreciate that transparency too. One of the things that is layered in here, you had on one of your slides, API gateways, things like that. We think about API economy, API designed applications. Of course, most applications aren't that way today that have been developed. That's something relatively new, not brand new. But there are all kinds of formats of interfacing with data. JSON, you mentioned time series. There's streams and graphs. Data in a lot of different formats. How do you work in an environment where there are not a consistent set of standards of how data is represented or you're accessed in some API type mechanism?
So you're talking about more sort of an unstructured type
with
scenario.
A variety of interfaces to data.
Right. So to a certain extent, at the interface level, we're constrained, like everybody is. Right? I mean, at some point we have to. There's only so many interfaces that we can expose to the data models that we host. Now, there's a lot of flexibility in those tools that Redis exposes, or those interfaces that Redis exposes. So, for example, when you insert data into Redis, say as a hash, it's naturally searchable. So if you think about building up a user profile, if you inserted that data, if you inserted user profiles using a hash data structure, you could literally drop search, the Redis search, on top of that, and all that data would be indexed. This is a pattern which is very familiar to someone coming from a relational database background, where they, no matter how they insert data into their rows, they can always come up with a select statement that pulls that data out. We do the same thing by using search. We provide that generalized language to get back data if that's the model that you want to follow. So I would say that coming back to your question, the best way to use Redis, probably any product for that matter, but let's talk about Redis specifically. The best way to use Redis is to actually think about how you're going to use that data, and then organize your data so that the interface makes sense, so that it's optimized for whatever it is you're trying to do. We also provide you the way to leave that open-ended. So my example of moving relational data into hashes and then using search. We can provide that query language if you aren't ready to solve for how you want to interact with your data. Did I hear your question correctly?
Yeah, I totally get it. That's sort of your way of abstracting those things, right? That complexity and giving you a query language, if you want to think about using that.
Yeah, exactly.
Air quotes.
That's exactly right. Yeah.
Carlos made a comment in chat. Just want to get your reaction to it. He said about the transition, keeping the old monolith app running in parallel while containerizing part of it. I've lived that scenario actually, where you took the part of the application that you needed to make enhancements to more quickly. It's more dynamic. Maybe it's kind of the future part of the business versus legacy. Right. And that's actually a strategy that's worked. Have you also experienced something like that?
Yes, absolutely. And that was kind of touched upon that earlier. You could, at one extreme is just caching, just caching the data so that you can use it for real time, but your system of record continues to be the legacy system. You're also in a position, if you're following that CDC pattern, to start to break off that data. You continue, 80, 90, whatever % of your legacy system continues to hold that data, but you've identified operational data that you actually can carve out, that you can move to your modernized application, and then you break the link so that now, whenever you want that data, you're always going to the modernized app side, and everything else remains in your legacy system.
It can be done. It's actually a good strategy. So I'm the analyst. No one paid me to ask this question. I don't want to think it's just a softball, but I'm really interested in your perspective on it. Today's webinar is sponsored by Red Hat Marketplace. We're talking about OpenShift in your presentation. Talk about why Redis and OpenShift. What's powerful about that combination? What are some of the really kind of interesting, cool, valuable things that customers can do because of OpenShift and Redis together?
So, I mean, it really is a better together story. And let's start with OpenShift. First of all, I can deploy OpenShift everywhere. I'm not constrained. I get that consistent development environment, and operationally, I have consistency no matter where I deploy. So if you think about from a DevOps perspective, one way of doing things, no matter where it lives. From the perspective of orchestration, I can rely on this platform to assuming the hardware resources are there, to maintain my description of what I need to run whatever my applications are. So no, I don't have to. If I were to deploy on bare metal, I have to worry if the node goes down. I have to worry that disks have failed. I can rely on this underlying platform to take care of all of that orchestration for me. Redis Enterprise also has orchestration, but it's operating at the data level. We're thinking about where is our data distributed across this platform. We're thinking about have we maintained safety in terms of HA, because we don't want one node to contain both the primary and the secondary shard of data. We lose the node, we lose the shard. And so we don't know about the underlying machine, but we do know about our data. Now you combine these two. And so the Redis Enterprise integration with OpenShift is using an operator pattern. And effectively what that means is we're telling OpenShift, we're telling OpenShift that this is how we need our system organized. We want to use anti-affinity to make sure that things are spread apart, and we're also listening for signals from OpenShift about what's changing, and then we can react to that as well. And so you basically have this coordination of orchestration, the platform side and the data side, achieving whatever the requirements are for that system.
Cool. And of course, you run in multiple cloud environments too, as well. So I'm really curious. You mentioned the fraud detection as the example
Right.
use case in your presentation or in your slides, and I think emphasizing, of course, the real time nature of Redis, and obviously people create products for a reason, and I think that's one of the key reasons why you brought Redis to market. I'm really curious as more and more not only pushes into the cloud, but of course we also have the edge, right? Where things are happening, whether it's on users' devices or even kind of on the geo edge, if you will. Data is present there too. And so that's part of this kind of fabric, this data architecture that you're talking about as well, correct?
Yes, absolutely. And tried to hint at that a little bit with the AWS Wavelength Zone. Those are literally running in telecom edges. So now instead of being 100, 150 milliseconds away from the data, you're 20 to 50 milliseconds away from the data. And the reason that you even care about that edge is the amount of compute you have in a silicon on a chip attached to a lamppost is pretty limited. And now think about an entire city of that. If you can now aggregate that data at a telecom edge and replicate that data in an active way, you have a very powerful set of compute, both local in the sense of it's only 20 to 50 milliseconds away from all those lampposts, and you have the full hyperscaler when you replicate out to a non-wavelength zone, basically a non-edge zone.
Yeah, you mentioned hyperscaler, Tanzu with VMware, another environment, of course, that you work with. Alex, who just chimed in on chat, who's from Nairobi, by the way. So we are global. We have India, Nairobi, Canada, all over the place. Minnesota, not that that's a foreign country, but no, sorry, Mark, who's from Minnesota. He said he's really keen on hybrid cloud orchestration by OpenShift. Yeah. And of course, the data architecture is extremely important to that. Why do you think orchestration is an important element of this, and how do you think about the data architecture and replication in an orchestrated environment?
Sure. So orchestration is when we're talking about OpenShift and then data, there's a bunch of different layers. So let me
it is clear sort of a substrate there, isn't it? Yes.
Right. So the challenge with any Kubernetes deployment is describing where you want the system to be on day 0, and then making sure that it evolves on day 1, day 2, day 3. So if you think about Helm charts versus operators, a Helm chart is great for day 0. Describes where I need to be when I stand the thing up. The question is, what do you do on day 1 when something's changed? When something's changed in the environment, you've had a node failure, you need to migrate your resources around your cluster. So that's where the operator, and by extension the orchestration of OpenShift comes into play. That you have this underlying platform that's continually trying to achieve what's been described to the operator in terms of distribution of resources, keeping certain things isolated so that you have high availability, making sure that there's enough free resources, whether that's memory or disk. So there's that element. Very similarly with your data, you have this notion of describing what you want your cluster to achieve, what you want your cluster to look like. So at its most basic form, I have a couple of shards of data in 3 nodes, spread out across 3 nodes in my Redis Enterprise cluster. What happens as I increase the data load? I add more shards, I add more nodes. I want to be able to describe how that system needs to look beyond that first deployment. So I need I need the underlying system to continually consider that, coming back to the example of my data shards on a single node. I want to make sure that I want the system to be making sure that I'm never getting into that situation, because I never want to lose a node and lose all my data. So I think that, that's sort of the layers of orchestration that come into play here.
Cool. Just want to remind our audience, thanks for hanging in there with us. We are giving away 4 gift cards at the end here, so hang tight, and we'll let folks know who those winners are. One of the things that fascinates me is the data world from providing a product. And we used to think of this strictly as just, NAS or storage, hardware storage, right? Solutions. And now it's all in software, virtual, and in cloud. I mean, you have the real-time aspect of databases. You have, of course, HA, but you also add into this, auto scaling. And you mentioned sharding and resharding, rebalancing of data across those environments. That maps right together with your orchestration, right? Is that the state of Kubernetes from the day you deploy to the day to tomorrow, or maybe it's 5 minutes later, can be very different. Talk about auto scaling, resharding, rebalancing, things like that, how that plays into a Redis environment.
So again, Redis on top of OpenShift. We know if I deploy in that scenario, we know that if I go beyond my initial, let's say I have 3 Kubernetes nodes that I'm deploying my data to, and I exceed the capacity of that particular Kubernetes cluster, we know that we can grow the cluster. We know we can add nodes. Very similarly with Redis Enterprise, we can, depending on need, we can grow the database, whether that means spreading the shards out so that we take advantage of nodes that have less resources being consumed, or perhaps spreading out, redividing the data, so resharding, so that we can get parallelization. Let's say that there's a very common query that needs to collect data from a number of different keys. If I distribute that query to keys living on different shards, I effectively get parallelization in that query. I can basically to fan out, fan in. So these are the elements that come into play. You mentioned specifically auto scaling. There's a balancing act on auto scaling. Is your system actually making the right choice? Is part of that balancing act, because it's not always that spike that means that you want to scale. That spike could actually be a really poorly designed application, and no matter what you do with your data, you're going to continue to get spikes. You don't want that to just be the cause of your auto scaling. So while yes, I mean there are times when you've planned for a peak load and you want things to expand to account for that, just blind auto scaling scares me, I guess is maybe the best way to.
So really good, bad, really good, bad. There's some good English. Really good, bad use cases. You don't want to auto scale in the middle of a DDoS attack because you're just adding more capacity to consume resources, right?
Exactly.
Probably not a good use case scenario. Well, we have a few more minutes left here before we wrap things up. I know that you all have a download center where you can get access to a lot of things from Redis and do a 30-day trial. Of course, getting access to product is one thing. A lot of it is, how do I use this stuff? What's some good use cases? How do I configure? How do I kind of think about solving my particular problem? Can you talk a little bit about some of the resources that you have available to someone in our audience that might be saying, yeah, this sounds pretty cool. I'm going to go check this out.
Absolutely. So in addition to being able to get a 30-day trial to the product, there's a free cloud version of Redis Enterprise that's also available. So go to redis.com, I'm pretty sure in the headline there's a sign up, and there's a free tier of Redis Cloud, meaning you don't. I mean, Redis Enterprise is a cluster-based architecture. So if you're just trying to kick the tires, do you really want to stand up your entire Kubernetes environment and deploy a 3-node cluster, or do you want to play with the thing and see how it works? So cloud is a great option there. In terms of learning how to work with a Redis database, we have Redis University, and through Redis University, there are 100-level courses just around data structures. There's a course just on search. I'm trying to think, there was there's courses on security, so basically some basic administration, and then courses that focus on the different SDKs. You can integrate Redis pretty much across every programming language you could imagine. Obviously, the popular ones, Java, Python, Node, have a course in Redis University. So really great material. The Redis U team is fantastic. And on top of that, they also publish all kinds of YouTube explainers and whatnot. So once you get beyond the basic data structures, if you want to know patterns around, for example, leaderboards, there's an explainer for that.
Good. There's a lot of good resources too. Also want to mention on Red Hat Marketplace. Boy, it's getting to the end of the webinar,
yeah.
Isn't it? You just search for Redis, and a lot of good information there. Kind of ready to go to run with OpenShift. If you're already using OpenShift, or you're just getting started with it, because I kind of go through the basic installs, upgrades, lifecycle, deployments, etc.
Exactly.
So super helpful there as well. Well, Andre, it's this has been a lot of fun, both to listen to your talk up front and also get a chance to interact with you and ask some of both the audience and my questions. And you've done a fantastic job. And thank you for sharing your knowledge and some of the challenges that we have in the data cloud distributed world that we, I think, enjoy living in on a daily basis. So thanks for everything today.
Thank you. Appreciate it.
You bet. I want to remind everybody that we are sending an email to all our participants, all of our attendees today. And thank you for participating in our chat and Q&A. And we'll send you a link to the recording as well as the slides that Andre used in the beginning. And of course, our 4 gift card winners, Amazon $25 gift card winners, are going to Tan M, Christian L, Lewis M, and Lydia E. I feel like I'm on a game show or something.
Congratulations.
Congratulations to all our winners. Come on down. The folks at DevOps.com will be getting a hold of you about how to get your gift cards. So, I really appreciate everybody joining me in thanking Andre Srinivasis, who's Global Solutions Architect with Redis, and also to the Red Hat Marketplace folks for sponsoring today's webinar. We hope that this has been helpful, informative, and we really appreciate how you helped shape the webinar itself through all of your participation. So on behalf of Andre, thanks to everybody, and we hope to see you again soon. Check out DevOps.com for a lot of other great webinars in the Red Hat Marketplace webinar series and more. And we hope that you'll join us again. Thank you, Andre. Thank you, audience. We'll see you all again soon.